Hey guys, welcome to Tier 2 Learning. This is Mr. Murphy. I have your short presentation that you should be watching on Wednesday. Your playlist for this week, let's try and get it done by, let's say, Friday at the latest. We do have a project that you'll be working on part of Friday and then into the early part of next week, okay? So let's just kind of iron through the different things we are going to be talking about this week. Remember, before break, we were talking about things like kinetic energy, potential energy, gravitational potential energy. This is kind of the wrap-up section. It's like a mini section. It really should be part of the energy chapter, but I wanted to make sure we got a test in before we hit Thanksgiving break. So this really is kind of like the last part of the energy chapter. We're going to be discussing work and power today. So it's really just kind of an extension of what we've been talking about, okay? So for our warm-up question, to kind of get us thinking back to what we were talking about before break, what is happening when an arrow and a bow is pulled back and eventually fired at a target? How is energy changing throughout this time? So if you're watching the video, I advise you to go ahead and pause the video, write down a couple thoughts or answers to this question that I've kind of posed to you. Okay, hopefully you paused the video. Now I kind of want to bring you back into the discussion of what we were talking about before break. So when the bow is getting pulled back, remember, you are gaining potential. You're gaining potential energy, right? Okay? And then when you release that bow and fire it at your target, that energy is transferring from potential to kinetic. Okay? So during this time, we pull the bow back, we're gaining potential energy. As the bow is firing forward, it's losing its potential energy and changing into kinetic energy. But remember, because of the law of conservation of energy, we're not actually losing or gaining energy in general. It's just changing its form, right? So just kind of keep that in the back of your mind as well. So that kind of takes us into what we're going to talk about today, which here are your I can statements. I can recognize that work is equal to the amount of energy entering or leaving a system. Okay, so recognize that here is what we are talking about today, and here is what we talked about previously before Thanksgiving break. So we're trying to marry what we talked about before Thanksgiving break to what we're talking about today with work. There is going to be some more math involved. Work is equal to force times delta x, which is distance. Okay, force times displacement. I can design or improve a system that involves work and energy transformation. We'll do that next week. You can conduct investigation. You'll do that next week. And then we can utilize the power equation to figure out how much power is in a system. So let's talk about work. What is work? Take a minute, pause the video, write down some thoughts. What do you think about when you hear the word work? What are some things that come to mind for you? So pause the video and write those down. Okay, so some of the things you might have written down were things like lifting weights, okay, maybe walking upstairs, maybe some of us even talked about doing something at a job, okay, working a job. Okay, the reality about all these things is that the science definition of work, our definition, actually takes place every single moment during every single day, right? It's kind of the cool part about science. It's something that I talked about at the beginning of the year. But our definition of work in science is taking place at different points throughout a day. When you're lifting weights, you know, you're performing some sort of work. You're using some sort of energy. When you're walking upstairs, you're using energy and you're using force in your legs, right? no matter what kind of job you want to work, or maybe what kind of job you do work, you're going to use force at different points throughout the day in that job, right? Whether it's just picking up a pencil, setting down a box. If you work for something like Amazon and getting ready for the Christmas holidays, you're always using work and you're always using force and distance throughout your day, okay? So let's just put applicable everywhere. Okay, because no matter where we're going, we're always moving, we're actively doing something, right? So that's where this work definition applies. So here is our formal definition of work, and I will go ahead and get this in red. Okay? Our formal definition of work is energy transferred to or from an object I spelled that wrong. Via the application of force along a displacement. So pause the video if you need to get that definition down. I am going to talk about this kind of definition of force and how it's going to lead to our formula. So work, the definition reads as energy transferred to or from an object via the application of force along a displacement. Okay, so the big things here are, one, we are using energy, okay, and how energy is changing, how energy is transferring, okay? That's really important in this process, okay? So we're going to talk about things like energy transferring from potential to kinetic or kinetic to potential, okay? We're going to look at how that applies to objects, okay? And then the last part of this definition of an object via the application of force along a displacement, okay? We all might remember that force can be represented with a capital F, and displacement is going to be represented with this delta x, okay? And that's something that we talked about earlier in the year when we did things like our average velocity formula, okay? Remember, our average velocity formula was distance divided by time, right? Delta x divided by delta t, okay? So displacement is similar to the idea of distance. It's something that we talked about a couple of weeks ago. If you kind of forget what distance and displacement are, remember that displacement is the shortest distance from point A to point B, but distance covered might be further. So if this is A and this is B, all right, I am trailing a long distance here, right, in all of these curves, but my displacement is just that straight line distance from A to B, okay? So our definition or our formula for force is going to end up being work equals force times, and we'll call it delta x for displacement. So work equals force times delta x, which is displacement. So let's work through a practice problem now. An 80 Newton force has been applied to a block and moved 20 meters along the direction of the force. How much work has been done to the block? So if we come up here to our formula, we have W equals F times delta X. Let's write out what each of these variables is equal to. Okay, an 80 Newton force, so that's going to be F is moved 20 meters along the direction of the force. So our delta X is going to be 20 meters. How much work has been done to the block? Okay, so the W is what we want to find. All right, so if we set this up, W equals F times delta X. W equals 80 newtons times 20 meters. Okay, go ahead, get your calculator out. I'll give you a second while you type that into your calculator. All right, so if you typed that into your calculator, you should have gotten 1,600, and we are going to measure work in this unit of joules. Okay, joules. Okay, that's the energy transfer that we're talking about. Cool? Because remember, joules were the unit of energy for kinetic and potential energy as well. All right, so now let's talk about power. How is power different from work? Power is very similar to work. All right, the only main difference in power is that it's going to involve time. Okay, so power is the amount of work done in a particular time frame. Okay, so power is the amount of work done in a particular time frame. All right, so the big thing here is if I have lifter A and lifter B, okay, let's say they are both down in the weight room lifting weights. They both decide to curl a 30-pound dumbbell. Okay, so lifter A, lifter B. Let's say they both curl a 30-pound dumbbell. Lifter A does this in 1 second, while lifter B does this in 2 seconds. Who did more work? Well, since they are lifting the same amount of weight, okay, or the same force is resisting them, all right, excuse me, all right, they are doing the same amount of work. Now, here's where the difference comes in. Who had more power? All right, lifter A would have more power because it took him less time to do that. Okay, and that can be represented by the formula for power, which is power is equal to work divided by time. All right, so power is equal to work divided by time. So if we do our example up here with lifter A and lifter B, lifter A, all right, would have had his answer divided by 1. Lifter B would have had his work divided by 2. Okay, so the one that did it in less time actually applied more power to that particular lift or that particular job, whatever it was that they were doing. Okay, and we can work through a practice problem here. An engine reaches its top speed from rest in 8 seconds. It is able to perform 345,000 joules of work in that time. How much power does the engine have? Okay, so our formula is power is equal to work divided by time. the 350,000 joules of work. 345,000 joules of work. Going in the work spot. It took us 8 seconds to do this. Type that in your calculator, and that'll be your answer. So the answer I got was 43,125. And the unit for this is going to be watts. Okay? Watts. So that kind of wraps up our discussion on work and power. There is now a short, I called it a playlist, but it's really more of just like a wrap up on this type of stuff. And there will be a short 3-question, 4-question checkpoint for you guys to take as well, okay? So that playlist is on Schoology for the blue and gold groups. I do have hard copies for you. I think we're going to watch this video on, today's what? Should be Wednesday. We'll be watching this video. So if you have questions and you're in class, you can ask me. But I'm going to try to get that playlist to you guys for the blue group on Wednesday. That way you can work on it Thursday if you need to. And if you are in the gold group, you will work on it. I will give you a hard copy on Thursday then. And you can start to work on it online as well. Everything's on Schoology per usual, okay? We will next week be doing, and at the end of Friday, maybe be doing a sort of roller coaster project where you guys are kind of designing your own roller coaster, and you get to talk through the different types of energy being used, how does work apply, and all that different types of stuff. So lots of fun stuff happening here over the next week and a half, 2 weeks. I look forward to seeing you guys all in school over the next couple of days as we filter in and out during the Tier 2 phase. So appreciate your time. Go ahead and get started on your playlist and let me know if you have questions. Thanks.